everybody, it's Mrs. Costello. This is the first day of Unit 10. We're going to do logarithms. So you're probably listening to that word and you're like, I have no idea what that is. On our graphing calculators, we have a button called log, and I know that you have been super curious what that means, and you're like, I can't leave Algebra 2 without knowing what the log button does. Well, today's your lucky day. We're going to figure it out. So, a logarithm is the inverse of raising something to a power. So, in all of our other units, when we've been trying to solve for a variable as an exponent, this is how we do it, by hand. And I know we love our calculators, but if you really want to know how to do it by hand, here we go. So, in our vocab box, we have our basic logarithm setup. You always have log with a little tiny b right here. The b is going to be the base, so I would label that. Because anytime you have an exponent, guess what? You have a base. And your base is right there as well. So, two bases, right? In logarithm form, the exponent is always on the right, well, not the right side, but it's always by itself. So, this would represent the exponent, just like this is an exponent, and you know that that's an exponent because you can see that it's an exponent. And then the y is kind of your product or your answer. I usually just put like what it equals. Okay. What it equals. There we go. All right. So, and we're going to kind of work switching between the two. Hopefully we'll get the hang of it. But if you see, like, my bases kind of stay on the same side. My exponents, they switched sides, and so did the y's, the answers, they switched sides. So when we start changing things into log form or into exponential form, I'm going to steal something from my friend Mr. Naughton. Mr. Naughton says base stays base, other two switch place. And I'll kind of go through that when we go through some examples as well. We also have something called a common logarithm. Now our common logarithm just kind of looks like this. If you just have log with just an x, so no tiny number, it's always equal to, like, so if something had a base of 10, so log base 10, so tiny 10 with the x. So if you ever see the logarithm no tiny number, your base is 10. We also have something called a natural logarithm. So the natural logarithm is called ln. Okay, last year we called her Ellen because, you know, we love Ellen. So if you want to call her Ellen, you can. And ln looks like this, log with a base of e. So that's kind of how we get rid of that e. That ln or ln is the opposite, the inverse of e. All right, so let's try to rewrite some of these logs in exponential form. So, number one, remember that the tiny thing is your base. So I see that I have a base of 2. Base stays base, so we are going to keep that as our base, our first number. Then my other two switch places. I think Mrs. Rooker calls this the loop-de-loop. So the 3 is going to go on the other side with the 2. It is going to be our exponent. And the 8 is going to be on the outside. That's going to be our what it equals. And 2 to the third is 8, so hopefully that makes sense. Number 2. We do not have a tiny base, so sometimes I like to write in the tiny 10 that's supposed to be there. Because remember, if there's no base, you put a 10 in. So rewriting an exponential, my base stays base. My other two switch place. So the 1 is now my exponent, and the 10 is what it equals. And 10 to the first is definitely 10, so I totally did that right. Number 3. Log base 16(4) equals 1/2. So base stays base. The 16 is the base. The other two guys switch places. We're going to use a rainbow pen because this one's kind of crazy. The exponent is now 1/2. And the product is 4. What it equals is 4. And 16 to the 1/2, remember that's a square root. So that is absolutely correct. Now we have this ln of e. Remember that ln is basically just log base e. So you can just put, on this one, you can just put e to the first, because this is still going to be your exponent. There's still a little e right here for your base, and it should equal e. And that makes sense, because, oops, sorry, this one also switched places. E to the first is just e. Okay. All right, why don't you guys go ahead and pause your video and put 5 and 6 in exponential form. So go ahead and pause your video now. When you unpause, you will see my answers. So pause your video now. Okay, here's my answers on 5 and 6. Should be pretty self-explanatory, but if you have some questions, you can ask your teacher tomorrow in class. Right. Now we're going to do the opposite. We're going to rewrite in logarithmic form. So remember that the base stays the base. So my base on number 7 is a 6. So I'm going to go ahead and start with log with a little 6. That's my base. And remember that my other two switch place. So the 36 is going to be with my log equals the 2 because they just switch sides. Same thing on number 8. So my base is the x. So I'm going to start with log with a base of x. And remember that my other two are going to switch place. So the 3 is now with the log equals the 2 is on the other side. We switched places. All right, go ahead and give it a try for yourself. Pause your video and do number 9. And there's the answer to number 9. So make sure it looks good. Otherwise, you can always ask in class tomorrow. Right, the rest of our notes, we are evaluating logarithms. So we're basically going, okay, what would be on the other side of that equal sign? Now, there is no equal sign. I know normally we're not allowed to do this, but I'm giving you permission to put in your own equal sign. So we're going to put equals x in there because we're trying to solve it. So what I would do is I would change each one into exponential form just so you can see it a little bit better and you can go, okay, x is going to be this. So base stays base, so keep that 3 as the base. The other two switch place, so x is your exponent, equals 9, all right? So what would x need to be for 3 to turn into a 9? Definitely a 2, okay? So 2 is what would be our missing number, okay? I'm putting the x's in. You can totally put the x's in. Check with your teacher to make sure that's cool, though. All right, same thing on number 11. Let's go ahead, say, okay, equals x. All right, base stays base, so 2 is my base. Other two, switch those places. So x is going to be the exponent, equals 16. So 2 to the power of something is 16. I know that 2 to the 4th is going to be 16. I'm going to kind of go through these a little quick, just because they are kind of quick ones. All right. Number 12. I was going to have you do number 12 on your own, but changed my mind. So, we can do number 12 on our own. The only thing I want to remind you of is let's put that 10 in for your base. Okay. Now I think you could totally do it on your own. So go ahead and pause your video and do number 12. Here's my answer on number 12. Remember that when there is no base next to the log, you always use a base 10. That's why I drew that tiny 10 in there. So if you have questions on that one, ask your teacher tomorrow in class. Okay, let's look at number 13. 13 is kind of tricky because, number 1, there is no base, so we do have to put in our 10. Now, I don't really like working with this decimal, so I'm actually going to rewrite that as a fraction. So this is 1/1000th. So let's see what that looks like after I rewrite it. So I'm going to write log 10, 1/1000 equals x. Now I'm ready to evaluate this one. So base stays base, so 10 is my base. The other two are going to switch place. So 10 to the x equals 1/1000. Remember that if my exponent is a negative, I make it a fraction. So I know that 1,000 is 10 to the third. So I know that my missing piece is going to be -3 because that's going to turn it into that fraction. See, a couple things I had to remind you about on that one. 14, okay, base stays base. Other two switch place. So my base is going to be 25. So 25 goes right here. And let's go ahead and switch these guys around. So to the x equals 5. Now this one's a little trickier because the 25 is getting smaller. Now remember that we can also have fraction exponents because our fraction exponents allow us to make radicals. So I know that the square root of 25 is 5, so I know that my x would be 1/2 because raising anything to the 1/2 power would square root it. Okay. Number 15. Okay. Number 15 is kind of weird because we have this 3 in the front. We are just going to kind of ignore the 3 for right now. We will work on it later. So the 3 is just going to hang out. Now remember that our log has a base of 10 because you can't see it, and we're going to put it equals to x. So we are going to go ahead and change this to exponential form. So my base stays the base, so 10 is the base. Other two guys, let's switch those. So 10 to the x equals 1. Okay. All right. So basically what happens is we just have to multiply the 3 by whatever we get. So when we have 10 to the x equals 1, we have to think about, okay, what would we raise the power to be 1? Well, anything to the power of 0 is 1. So I know that x equals 0. So like if we were actually evaluating this, we would have 0. So 3 times 0, which is just 0. So that one, I know the 3 is not super necessary, but that's what you would do with it if you wanted to. All right. You guys are going to pause your videos, and you are going to do number 16 and number 17 on your own. So go ahead and pause your video now and do 16 and 17. All right, here's my work on 16 and 17. Make sure you're keeping your bases and swapping the other two on each side. So those ones, hopefully, we're good to go. All right, so number 18. 18 is kind of tricky. If you really wanted to do it the way we've been doing it, you absolutely can. But this is also one that has kind of a special rule that we're going to talk about a little bit later. So if we're still using what we've been doing, if we're keeping the bases the same, the base is 8. And the other two, right, change place. Base stays base, other two switch place. We have 8 to the x equals 8 squared, huh? Well, that one's pretty, self-explanatory, right? Look, the x is an exponent, and this 2 is an exponent, so x would equal 2. Now, let me show you a shortcut you can use, because we just did it the long way, and I showed you why our shortcut is going to work. Because I have a base here, and technically this is a base here, those guys will always cancel, and you'll just be left with that exponent, that 2. So either way is fine. If you forget the shortcut, you can always do your base stays base, other two switch places, or you can totally just use the shortcut, which is also very nice. Okay. Guess what? You get to make that choice right here on 19. So go ahead and pause your video and do number 19. All right, here's my work on 19. I showed 2 ways of doing this. So there is an or. Either way, you should have gotten X. So that one's not that bad. Number 20 is another one where we can use a shortcut. So this 3 is being raised to a power of log base 3. So the 3 is the base here. The 3 is the base here. See how the bases match? When the bases match, we can go ahead and get rid of that, and you're just left with your exponent 9. Okay, very similar to the last one. 21, we are still going to set this up, but I'm going to kind of show you that this one's a little weird. Okay. We are going to keep our base the same, so our log base of 8, so 8, other two change place. So x over here, 4 over there. Now this one's kind of tricky because they're two different bases, right? And there's no way to raise 8 to a power to get 4. So what we are going to do is we are going to change the bases, which is something we are going to get very good at in this unit. So we're going to change those bases. We're going to change them to be the same. Now I know that 8 is 2 cubed. So I'm going to do 2 to the power of 3, but that x is still there. So let's keep it as 2 to the 3x. Then I'm going to do 4 is 2 squared. Okay. So same bases, right? We can go ahead and cancel those guys. Cancel, cancel. And we can set those guys equal to each other. So 3x equals 2. Go ahead and divide by 3. So our missing number would be 2 over 3. And that's a little hard to get to on your own, which is why that change of base is really nice. Okay, backside. I know these ones are kind of quick. I'm trying to keep this video short and sweet. Alrighty, go ahead and you can pause your video and you can do number 22 on your own. All right, there's my work on 22. Again, I showed both ways just in case you're still having trust issues with my shortcut. Either way, I will not take offense, so we are good to go. 23. All right. 23 is not awful, but let's just go through it anyways. Base stays base, so 25 is my base. Other two, let's switch place. So 25 to the x equals 1/5. So I know that I could get 5 from 25 if I square rooted it, but then I have that fraction, so I know that my exponent needs to be a negative. So negative 1/2 would be good for 23. 24. Now 24 is technically missing the base on the log, but the log is an exponent. So let's be careful with it, right? So we're going to write the 10 raised to the power of log base 10, right? Because when it doesn't have its base, remember it's base 10. So same base, base and base, cross off, right? And we're left with just the 2. Again, if you want to use my shortcut, awesome. If you don't, you got to do some crazy stuff, so. All right. Go ahead and do 25 on your own. So go ahead and pause your video, do 25. There's my work on 25, right? Same base, same base. So just should have been x on that one. Right. 26. Now 26, when we have e and then being raised to the power of ln of anything, E and ln are opposites. It's kind of like when you had, the power right here with the 10 being raised to a log, like those are opposites. Those guys kind of match too. So when that happens, you can just cross these out again and you're left with your exponent. Same thing with 27. I have e being raised to a power of ln. These guys are inverses of each other. Boom, they will cancel. So I will just have that x left. Kind of nice, right? Alrighty, 28. Let's put our equals x. Okay, base stays base, so the base is 2. The other two are going to switch place. So 2 to the x is going to equal 16 to the x. Okay, this is one where I'm definitely going to have to change the bases so that they match and I can cross them off and I'm happy. Okay, so 2 to the x equals, let's go ahead and change this guy to also be a 2, right? So 2 to the x equals, well, 16 to the power of 2, that's going to be 2 to the 4, and then you're going to have your x. Okay, so the two bases, right there, are going to cancel each other, and you're just going to be left with this guy, the 4x. Okay. And we can also change the base in logarithmic form, which is what I'm going to do right here. So, I can change the base now if I wanted to. If I'm looking at this and I'm going, well, 27, I could change that to be a power of 3 because 27 is 3 cubed. So log base 3, and then 3 to the power of 3 is 27, but just add that x on. Now I have matching bases, so I can go ahead and cancel those, and 3x would be my expression simplified. Number 30, let's go ahead and put that 10 in. That's a log base 10. And let's keep our base the same. So keep that as 10. And base stays base, other two switch place. So the x is the exponent, equal to 0. Okay, could I get anything equal to 0 by raising it to a power? That is a no. So this would be a no solution because that doesn't work. And that's okay. Sometimes we get those. Same thing on 31. Let's go ahead and put in that base of 10. Okay, base stays base, so 10, and other two switch places. So 10 to the power of x equals negative 10. Well, I definitely can't turn the 10 into a negative by putting an exponent in there. So this one is also a no solution. All right, the moment you have all been waiting for. No, it is not the end of the video. It is the time to use our calculators. Yes. So on our calculators, we should have a log button. I'm going to go ahead and pull up my calculator. Okay. On my calculator, look, there's this button right here that says log. You literally just push the log button. And then, wow, there is an ad. That's really nice. Thanks, Mr. Goodfellow, for putting this on my computer. Anyways, log base 26, and then push enter. And it looks like we're going to do 1.41 for our... Okay. Same thing with number 33. Number 33 is ln. So literally right below log is ln. So I'll put ln in, and my value is 0.45. And all I got to do is push enter. And my decimal is negative 0.798. Let's go ahead and round this to, so negative 0.80. All right, now we are almost at the end of the video. Just in case you need a refresher or, I don't know, something to put on your cheat sheet for your test, let's do a recap on our rules. So whenever I have a 1 right here, I know that that's going to switch places. I know that anything raised to the power of 0 is 1. So that is going to be a 0 right there. Remember that ln and e are they're opposites. So when they're right next to each other right here, you can cancel them out and you're just going to have x left. Same thing right there. I know you don't see x, but we would just put a 1 in on number 3. ln and e right next to each other are just going to make 1. E raised to the ln of x. Remember, we can totally cancel those guys as well. And that is going to be an x because those guys are inverses of each other. Okay, number 5, we've got matching bases. Matching bases, guess what? They get to cancel, and we are left with whatever x is. And same thing on 6, matching bases. Let's cancel those guys. We are just left with the x, which is kind of nice. Okay. Last thing right here, domain of log of x equals x is going to be greater than 0 always, unless, I don't know, we shift something. And that is something for day 2, Mrs. Costello, to talk about. So we are done with day 1. If you have any questions, feel free to, ask in class. Otherwise, enjoy the rest of your day.